Now we will go to the presentation session. We are slightly a little bit late on our program, so I would like to ask all the speakers to try to stick to the planned duration for the presentation. Our first speaker will be Mr. Luc Rens, Managing Director of EUPAVE, who will deliver a presentation on climate resilience and long-term vision of road. Please note that there will be a possibility to ask questions to the speakers after the presentation. There will also be a possibility to ask questions during the debate that will take place after the three presentations. But we are going to try to stick to our timing. So Luc, the floor is yours.
Thank you, Christophe. So my presentation is a very general one, a short introduction to the more detailed presentation of my dear colleague Jim Mack from Siemens, which will come afterwards. And my presentation is based upon a fact sheet that we drafted within our working group on environmental strategy within EUPAVE. It's a brief document that collects a number of statements, facts and figures on the different aspects of resilience to the direct and the indirect consequences of climate change. Well, we drafted it last year in 2021. It could not have been more topical at that moment, unfortunately, with the floodings in Western Europe and the wildfires in different places in the world. In our document, we focus on concrete roads, but to be clear, EUPAVE scope covers, let's say, all kinds of transport modes and infrastructure, such as pedestrian areas, bicycle lanes, bus lanes, heavy rail and light rail, and even air transport. In our fact sheet, we start with a few definitions. The first one you see, one from the Intergovernmental Panel on Climate Change, a long definition. I let you read it. You see it ends with maintaining the capacity for adaptation, learning, and transformation. Well, it's not easy for a hard infrastructure to learn and transform. So let's say that in our context, we consider it more as resilience as the capacity to absorb stresses, to remain functional in the face of external stresses imposed upon it by climate change. So we do focus now on the consequences of climate change, although that other hazardous events could lead to the same criteria, to the same conclusions. Let's take a look at two main consequences of our changing climate that affect our road infrastructure. So the increase in temperature and also the increase in precipitation. Or maybe it's more the increased occurrence of extreme temperatures. More heat waves will lead to a higher risk of rotting of bituminous surfaces due to the viscoplastic behavior of that material. More rotting is also a higher risk for aquaplaning, so it's a dangerous situation. Also, pre-thaw cycles will be intensified, mainly in the north and center of Europe, and that can accelerate the deterioration of different types of pavement. It will require adapted designs. And yes, another consequence of dry and heat periods or the wildfires. Very recently, we could hear in the news that the fire season in California is starting earlier and ending later each year. And obviously, climate change is considered as a key driver of that trend. The increased precipitation and the flooding disasters are becoming part of our lives. The main risk for the transport infrastructure or erosion of embankments and foundations or loss of road structure integrity, pavement integrity, and Mr. Mack will go more into detail of this in his presentation. And yes, we could be a bit more optimistic. However, if we look at the figures published by the European Environmental Agency and by the Joint Research Center of the European Commission in their technical reports, then it is not all that optimistic. 2011-2020 was the warmest decade ever recorded, with global average air temperatures reaching 1.1 degrees above the pre-industrial levels. And the rate of increase now for human-induced global warming is about 0.2 degrees Celsius per decade. And an increase in frequency and duration of extreme temperatures is also projected, mainly in the south of Europe. Projected increase in weather-driven fire danger in southern Europe is about 30 to 40% by the end of this century, compared with the end of past century. And the same is for heavy rain in winter and summer for Europe. So about the end of this century compared to 71, 2000, you see increases from 25 to 35%. So that is enormous. And another consequence of natural disasters is the necessary removal of debris. Unfortunately, trucks carrying debris are unavoidable in the event of severe damage after floods or wildfire events. And this transport mostly happens, but it consists of heavy goods vehicles driving on roads that basically have not been designed for that. It means an increase in unevenness, so less smooth surfaces, and also a faster degradation for asphalt roads was observed by researchers in comparison with concrete. Yes, we know that rigid concrete pavements are less impacted by overloading and provide a higher resilience to flood and wildfire damage. Well, here we see an infographic that we also drafted within EUPAVE. In the upper right corner, you see the higher resilience to climate change, but I also want to draw your attention to the upper left corner, less global warming, and that is about mitigation. There are two aspects. The high albedo, which is related to the light color surface, leading to a larger part of the incident light that is reflected to the upper atmosphere, slowing down global warming. A second effect is reduction of fuel consumption for heavy goods vehicles driving on concrete compared to asphalt. The following slides will give the figures. Here you see that when you change a black into a lighter color surface, asphalt to concrete, you save an equivalent of 22.5 kilograms of CO2 per square meter. And that is equivalent to about 30 to 60% of compensation of the CO2 emitted during cement production. And this is the figure for the reduced fuel consumption, up to 2.35% for heavy goods vehicles on concrete compared to asphalt. Also, that is a significant reduction. And another contribution to the risk of flooding is the use of pervious pavements. Both precast elements and in situ cast pervious concrete can be used for this purpose. You see a few nice examples on this slide. So the societal benefits of a resilient, robust road network are numerous. First of all, it saves lives, thanks to the positive impact on road safety, and also while guaranteeing a free traffic flow for emergency services, ambulances, firefighters. Secondly, it allows us to save money, thanks to the lower repair costs. And in addition, there is a lower impact on economy, thanks to the increased availability of the transportation network. And finally, this is also better for the environment, since there are less impacts from emissions and use of resources for rehabilitation or reconstruction of the infrastructure. Regarding the way to go ahead in building and adapting our infrastructure, I'd like to refer to a publication from the Organization for Cooperation and Economic Development, the OECD. It's called Climate Resilient Infrastructure Policy Perspectives. And I give you here a few statements. So infrastructure will be affected by the climate change, but it will also play an essential role in building resilience to the impacts. New infrastructure assets should be prioritized, planned, designed, and operated to account for the climate changes that may occur over their lifetimes. And existing infrastructure may need to be retrofitted or managed differently given climate change. Well, concrete roads are a part of that solution, either as a newly constructed pavement or as an overlay on existing concrete pavement. It is important to conclude that decision makers have access to a high quality information, to consistent data, so that they are able to manage the climate related risks. And a final statement is that public policies should promote resilience and include public procurement processes that consider climate resilience when comparing competing bids, simply by accounting for the cost over the asset lifetime under those scenarios. Ladies, gentlemen, I thank you for your attention.
Thank you very much, Luc, for this quite interesting presentation. Do we have any question from the audience? You have the possibility of raising hands or using the chat box. Well, it seems that either it is the end of the day or your presentation have been absolutely crystal clear, Luc. So if I don't see any question coming from the audience, I would like to ask you a question. You have shown a slide on the use of water permeable pavements, I think, or pervious pavement as the mitigation effect, can have a mitigation effect to climate change. And can you maybe explain a bit more what to which extent this pervious pavements are able to prevent floodings or to cope with those sort of extreme events or disasters?
Yes, I can. Well, the pervious pavements, water permeable pavements are a very good application. And in case of a very generalized use of it, for instance, on streets, sidewalks, also on private properties, this will definitely reduce the amount of stormwater that needs to be evacuated. So it will have a positive impact on the prevention of flooding. And let's not forget, it also plays an important role in the fight against drought and lack of groundwater. So it's also very important for that.
Right.
Now, on the other hand, I think in areas with a high risk for flooding, it is probably wiser to choose for a more robust design. Let's say I would rather go then for a base layer, for instance, in a lean concrete, which is maybe not permeable, but which will better resist the washout effect of a strong current compared to a water permeable unbound aggregate base, which would be less resistant. So I think, yeah, both aspects have to be considered. So the permeability, allowing the water to infiltrate in the soil, that is important, but also the robustness of the solution itself.
Okay, so then we can really see that the topic is more complex than we could suppose at the beginning, and you have to take different criteria into consideration. Thank you for answering this question. Is there any question from the audience?
Question in the chat, Christoph.
Is there a question in the chat?
Yeah.
How would you quantify whether a pavement is more resilient? I'm sorry, Stefan, I didn't see the question in the chat, but thank you for mentioning that.
Yes, the quantification is obviously a difficult aspect, but with my last statement, I already gave some possible solution. When let's say, in some cases, you do have to define the resilience or the robustness, or you have to look for solutions that will withstand the possible effects for future worst case scenarios. And that means that probably we will come to overall solutions which may be more expensive. Well, in that case, those costs should already be accounted for over the lifetime of the asset, taking into account. It is maybe like from other criteria, it may be easier in a PPP, public-private partnership. And in that case, it's important, I think, to clarify the allocation of the responsibilities regarding climate-related risk planning, management, and response. But
okay, thank you.
Hope this gives somehow an answer to, but of course, it's not a pure quantification of the resilience.
Okay, thank you for this explanation. I know, yeah, the person who said, who asked the question said, I know it's a difficult question. You try to give some elements, which is quite nice. I think that we would now have to go for the second presentation.